Hi, in this section, we're going to start talking about measures of location of data and where data is located to the scope of the data. And it doesn't seem like it would be that important, but it really is. Like to see the position of where a data point lies is important to evaluate what is on the right side of that data point or below it. Okay, so we first need to talk about percentiles, and I think that's the easiest place to start because we always hear our whole lives with standardized testing, oh, I'm in the 90th percentile. If you have children, it's like percentiles is everything with their growth. And oh, my child's at the 30th percentile in weight, but the 70th percentile in height. Like, what does that mean when everyone talks about percentiles? It is a position of data. That's all it is. It's a data point location in the scope of all the data. So for example, if we said that Ryan had scored in the 90th percentile, means that 90% of the test scores are less than Ryan's score and 10% of the test scores are greater than Ryan's score. So only 10% of all students who took that test, whatever Ryan took, did better than him. And he did better than 90 other percent of the other scores. So it doesn't mean he actually scored 90 out of 100. We don't actually know Ryan's score. We just know out of all the scores there, he scored 90%. All the scores are 90% less than his score, wherever his data location is. So, and we could use it for anything, right? So the kth percentile, denoted as P sub k, of a set of data of the such that k% of the observations are less than or equal to that value. So looking at the example, it says the graduate record examination, which is the GRE, is a test required for admissions to many graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admissions for their human genetics MPH or MS program. Interpret this admissions requirement. So what does this mean? Well, if I drew a number line for you from 0% to 100%, the 70th percentile, is it over here near 0, or is it over here near 100, or is it in the middle? You're like, no, it's like somewhere between the middle and the highest, right? And so maybe about here, Darlene. Oh, okay, then here's the 70%. So what does this mean? Here's this person's score, whatever that score may be, and this means that 70% of the scores are less than that score, and 30%, right? What's left, right? The 30%. Because 70 plus 30 gives you the total 100%. So this means that that data location for that GRE score, so it's a score you're looking at, that 70, so let's just say it was me that took it. So I would have scored, all scores would be 70% less than mine and 30% would be greater than mine. So they're looking for that 70% data location score. And so this means interpreting to the GRE and the University of Pittsburgh, we would say that students must score at least or better than 70% of all scores from the GRE. So out of all the students taking that exam for that entrance to the School of Public Health, it has to mean that your score has to be where 70% of the scores lie below it and 30% lie above it. It's just that data location barrier. So of course we love the quarters because the quarters are where we're going to be able to determine the 25, the 50, the 75, right? Quarters are really important to us in statistics. And so if we had 25% of the data, that means that first quartile and that 25% of the scores are below it and 75% are above it. The median, which is we call or Q2, is 50-50. It's the halfway point. And Q3, which is what you would assume 75%. So that's opposite than the Q1, right? Where we would have 75% are below it and 25% are above it. So the quartiles are interesting because from here we could actually discover some outliers to our data. We can have an interquartile range, which is the middle 50% by just subtracting the Q1 and Q3. So it'll be interesting how much we get out of these quartiles and these points of location of data. Okay, so when we have the Q1s to Q3, then we call them quartiles, and they actually are percentiles as well. Like Q1 is the 25% marker, 25% below it, 75% above it. Well, by definition, that means it's the 25th percentile, right? So let's go ahead and look at a graph. So here in the graph, we see the median here. It cuts it 50-50, right? Here's every quarter is 25% of the data. So Q1, notice, is 25%, meaning leaving 75% above it. Q3, we can see it's 75% below it and 25% above it. If we subtracted Q3 and Q1, we would get the middle 50%. So you notice we can get like a lot out of our quartiles, right? Those values. So there's a difference between the percentile and the actual quartiles. Quartiles are actual numbers and values in our data. And then the percents or the percentile are within 0 to 100%. The median is always going to be valuable to us. It's also known as a central value, a measure of central tendency. And when we interpret, we say half of the values are below it, half of the values are above it. And we would always interpret in context of the study. Because we just don't want to say, oh, it's the halfway marker, right? Oh, it's halfway. That's what it is. Like what? So like the weights of apples. It's like, well, the median, let's say the median weight of apples is 4 ounces in your study. Well, that means half of the apples weigh less than 4 ounces, and the other half of apples weigh above 4 ounces. So the 50th percentile, 50%, right? That is the percentile. And the actual median is the value that comes from your data. So in this graph above, with the quartiles and the smallest and largest data value, that's actually a special 5-number summary. And essentially, we use the 5-number summary to break up our data quite a bit. And so to do the 5-number summary, what you have to do is actually rewrite your data in ascending order, and then observe the smallest and largest value, and that would give you those 2 data points, which means there's 3 left. You need to find Q1 and Q3, right? And then that we could easily do that in the median by using the locators. So the locator is essentially associated with the percentile. Q1 will use 25%, Q3 will be 75%, and the median is half. I like this because this is like a method to finding the quartiles versus just trying to point it out. Okay, so I do have some data here. It is the data of the weights of models written out. And so if we go ahead and write the data smallest to largest, we'll be able to identify the quartiles. So we did write it from smallest to largest. That's already done for us. Okay. Step 2 is we can find the minimum value once it's in order, right? So let's go ahead and identify the minimum value. So the minimum value we can see is 85. Great. And so let's go ahead. I'm going to do it up here where it's like min, Q1, median, Q3, and then max. Or, yeah, max. So we just need these 5 pieces, right? So step 3 is to find the median. Okay, to find the median, it says that we should find the locator first. So the locator is going to be 0.5 n, where n is the number of data. And we do know that the number of data in our set is 16 because that was the number of models that we took weights from, right? So if we try to find the locator, it would be 1/2 times 16, which is equal to 8. Now, if we go back to the box, you'll see that there's 2 cases that we have. The first case is if L, the locator, is a decimal value, then round up to the nearest whole number, and that is the median. That is the locator. If L is a whole number, then find the mean of the data in that Lth position and the one to the right of it. So the locator is not the data value. The locator tells you which position it is. And if it's a decimal, then you go ahead and round up and then count over that many observations, and that's your median. If it is a whole number, go to that position and take the value to the right of it and take the average of those 2 data values. So in our case, it's a whole number. So this would mean that I need to look at the 8th data value and add the one to the right of it, the 9th data value, and divide by 2. Remember that this is a position. It is not the data value in your set. It's really important you understand that because you can't say 8 is a model's weight. It just says 8 pounds, just nobody is 8 pounds, right? So you have to be sure that you understand what you're doing. The locator is the position of the data. You use the locator to locate the data value and then take the average of the 2. So in our case, if I count here, here's the first data value, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I can see now the 8th and 9th data value is the data value 110. So I would take 110 and add it to the 9th data value and divide by 2, which is 110. Okay, so let's go back up here and I'll fill the median up with 110. Okay, so step 4 is now finding Q1. Okay, to find Q1, we need to use the locator method. So it's 25% of n. So this means L is equal to 0.25 of 16, which is 4. Now I want you to remember that this is a position. It is a whole number, and therefore I need to take the 4th data value, add it to the 5th data value, and then divide by 2. So if I do this, I would count over to the 4th data value and the 5th data value, which is 85 and 98. So 85 plus 98 divided by 2. I would get 91.5. is equal to Q1. So let me put it up here, 91.5. So notice it's in order too. 91.5 isn't larger than 110 or smaller than 85. It will be in between. Okay, so let's move on to step 5. Step 5 says go ahead and identify your maximum value. Okay, so that's not too bad, right? I can just go here. Oops. I can just go here and see it's 138. And so I'll put it here, 138. So I assume Q3 is going to be between 110 and 138. Right? Okay, so let's do step 6 over here, where we find Q3. Okay, so to find Q3, that would be the 75th percentile, and we would have to find the locator for that, 0.75 times n. So that would be 0.75 times 16, which is equal to, if you put it in the calculator, to 12. But recall that this is not the data value, right? This is a position. Because we obtained a whole number, we would have to take the 12th data value, add it to the 13th data value, and divide by 2. So in looking for those, the 12th and 13th would be, here's 10, 11, here's 10, 11, 12, 13. So here's 12 and 13. So I would add 115 plus 115 and then divide by 2, which is 115. So Q3 is 115, and we can see that it's in between the median and max. And if I wrote this out nice, I would say if I wrote this out nicely, we usually list it, the 5-number summary, separated each value by a comma in order, smallest Q1, medium, Q3, max. So let's go ahead and do that. So the minimum 85, Q1 91.5, median 110, Q3 115, and max 138. Okay, and the last piece to this was to find the IQR. And that's just going to be the middle 50%. So just subtract Q3 and Q1 in your calculator. So if we went over to our calculator here, let me hit second quit from our histogram, and I would just take 115 and subtract 91.5. And we would get 23.5. So the IQR is equal to 23.5. All right, and then we just want to make sure that we understand what the IQR is. Remember that if we scroll up to the number line here, the IQR is the middle 50%. So this means that the middle 50% of data values range by 23.5. If I send this in context of models and their weights, I would say the middle 50% of models' weights has a range of 23.5 pounds. That's what I would say.